Hello everyone. In this episode, we'll show how to do early stopping in neural network. Okay. So first we do the usual input PyTorch and check whether Google Colab is running. And then there's the early stopping, and the early stopping is there to prevent overfitting. You can run the whole data through for many epochs, and how many epochs should you run? Well, the answer is until you think that it kind of fits the function well, but doesn't overfit, so that it generalizes to the unseen data. Okay, so there's a training set, validation set, and holdout set. And what we do is that we train the weights on the training set and then see how in validation set it's working out, and keep doing it until it kind of the performance deteriorates in validation sets, although the training set error will go down. So the routine is really simple, and most of the time you will just copy this routine. So there's an early stopping class. The basically is governed by this patience, how long should you train and wait, the validation error, and the minimum delta. Um, specifies the minimum change you should be considered an improvement. And then the restore of the best weight, so that once you figure out that you passed the optimal point, you go back to the weight that were the best. Okay. And here, basically, the routines, basically simple thing that it counts whether the um, the validation loss is getting worse or not, and then check and stops when this is violated. So let me just show you how it's being done in practice, and we'll just use the usual thing. In classification problem, we'll just do the lone default example. So it's pretty much similar to the earlier episode in how to use PyTorch for neural network. And what you do here is that you have well, first clean up the data, of course, the X and Y variables for the lone data. And then you split the validation and training sets, so the train test split function. And then in this case, we scale it and then convert the torch tensor for the train and test data. So we do this. So once you do this, so the tensor data set, you could put the X train and Y train into the tensor data set, and the data loader set it up. Also same thing for the test data. And here's the neural network model that we used before, exactly the same before. And the model is here. And we use cross entropy loss and Adam optimizer. And here's the new feature. Here's the early stopping. We name it ES. So it's very similar. So you run every epoch and get the data from the data loader training data for each step. You basically get the model train. Okay, and what you do here is that you get the X and Y batch and get the prediction and get the loss optimizer, zero gradient, and then compute the gradient and update the weight. So this is one of the usual thing we do. All right. What we do here is that we evaluate the model here for the X test and get the prediction, and then get the loss of the prediction, and then the validation data, the loss, and compute it against the training data loss. And if this is kind of meets the condition for the early stopping, then we exit and do this. So, and if you actually run it, what you can see here is that all these stoppings kind of can happen when there's no improvement, right? The rest of them are fairly similar. You can do the same thing with the regression. You can use the same routine, and I'll just skip here most of the things, but here's the ES early stopping. And what you do is that in the validation data, you basically compute in the ES model and the actual loss for the validation data. And if the conditions are met, you basically will do early stopping. Okay. So it's very simple, and you can save and load the PyTorch to neural network. So take a long time to train. So it's usually you like to save the neural network so that you can load and use them later. So this simple code shows you how to do this. Okay. So you have the Boston housing, for example, training and the data set and data loader. And you all do this. Okay. But here you have the torch safe model in the file. And then what you can do is that you can compute and that's reads the data for prediction. The code loads the weights from the previous fit and do this. So this basically simple code shows you how to recycle the trained weights from previous exercises, right? All right, so this was a simple example of how to use early stopping. Thanks for watching this episode.